Alrighty, so we're looking at ionic compounds again. This will probably be the last day on ionic compounds. Remember that an ionic compound is a metal, which is where on the periodic table there, Christian? Where are the metals on the periodic table? Left side, correct. And the non-metals, of course, are over on the right side. So ionic compounds are ones with one from the left, one from the right. Read along with me here. Page 192. There are over 100 elements in the periodic table, and thousands of different compounds are formed when these elements combine. How can we name these compounds? How can we write formulas to represent them? In section 5.7, you saw that the periodic table and a knowledge of electronic structure could be used to predict the ionic charges of elements. As you go down the column, the charges should be different or the same? The same. As you go down the column, they should be the same. Elements in the same families tend to form ions with similar ionic charges. Such an ionic charge may also be called the valence or combining capacity of an element. You've heard me talk about valence, valence shell, valence electrons. It can also be referred to as the carrying capacity. Another word for it. Or combining, did I say carrying? Yeah, combining capacity. Figure 1 shows the ionic charges of selected elements. And you can see there's sort of a shaded in or a half done periodic table there, and you can see the different charges. Some elements with more than 20 electrons are included, although the electronic structure is more complicated than the model we've discussed so far. You're basically only going to be responsible for knowing stuff about the first 20 elements. After that, it gets way too complicated, way too quick. Metals and nonmetals combine to form ionic compounds by transferring electrons. The metals atoms lose electrons to form positive ions, and the nonmetal atoms gain those electrons to form negative ions. So the ones on the left do what with their electrons? They get rid of, right? The ones on the left get rid of. Good morning, Mrs. McDougall. All right, where was it? So we're talking about ionic bonding here, the carrying capacity. Oh yeah, ones on the left do what to their electrons? Yeah. Give away. Ones on the right, take them in. The giveaways are the positives. The take-ins are the negatives. Awesome. Okay. Blah 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 blah. Consider the compound aluminum chloride. Aluminum chloride. Aluminum has how many? What number is aluminum? Actually, if you just look here, 13. It's 13? Aluminum 13? Okay. Can you put the formula, please, later? Aluminum's 13, right? So that means like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And it wants to do what to those 3 electrons? Give them away, right? Chlorine is the other thing that we're winding up here. Chlorine is number what? It's number 17, isn't it? Right. Appreciate it. I think it's number 17, isn't it? Oh, I hate drawing these things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So chlorine's got room for 1. So this blue guy here goes in there, right? And the same thing happens there, and the same thing happens there. I think you get that. Not if you get that.
Can you please draw me off that?
Don't you even dare ask me that. Can you go to that for me? Do you get that?
No.
Don't give me that. I know you get it.
I do.
I think most people here get that.
This is quite simple.
Yes, it is quite simple. Okay, so then there's a whole bunch of crazy rules for naming it or writing the formula. Should I just flip over where the easy rule is?
No.
Let's just flip right to the easy rule. I don't even know why they bother with it other one. Okay? I'm now on page 193. It's so simple, you guys, right? What's the formula going to be? Well, clearly, how many ALs do I have? 1. And how many CLs do I have? Chance? 3. So it's going to be AL, CL3, right? Okay. Here's the easy way to write formulas. Look at the periodic table on here. What's the charge on aluminum? Right here on this page. Plus what? Plus 3. So here's how you do it. You just write aluminum and chlorine. Al is a 3 positive. Looking at this periodic table right here, Chance, what is chlorine's charge? Eh? Put your finger on there for me, Mike. What charge is it?
Negative.
Negative 1, right?
Yeah.
Negative 1. So we're just going to do this. All you do is they just crisscross. This 3 comes down there. This 1 comes down there. Do you need to write the number 1 in the formula? No, just writing the name means there's 1, so it's AlCl3. That's all it is, just that crossover thing. It is so simple. There's nothing to it. Okay? Let's try another one. Man's going to put his phone away so he can try another one. Otherwise, that phone's going to the ops. You guys really, come on. It's not that hard. Just leave it in your pocket. Look, mine's sitting right there. I'm even expecting the text. And I can I just watch it in case it buzzes? Yeah, I know. Come on, you guys. We got to do this. Okay. The next one is aluminum and sulfur on page 193. Aluminum and sulfur. Aluminum and sulfur. Nathan, what is the charge on aluminum from that periodic table on page 192? This Nathan that I'm pointing at. No, what did he say? I didn't hear him. 3, right? Other Nathan, I'll give you a chance to speak. What's the charge on S, sulfur? Come on, it's right there. It's on the top of page 192. S is up. Negative 2. 3 plus 2 negative. All you do, Christian, are you watching? All you do is what? Just take that number, put it down there. Take that number, put it down there. What's the formula for aluminum sulfide? Al2S3. That's all there is to it. It's really simple, is it not? Nod and say, yes, that's simple. Have I made myself clear, John?
Yes.
I've been speaking English?
Yes.
Everyone in the room should understand what's going on?
They should.
Okay, if they've been paying attention, right?
Yes.
Okay, now if you flip over the page, that's where they show all that stuff, right? Now, naming ionic compounds. Join me on the bottom of page 194. Naming ionic compounds. Naming ionic compounds is almost even easier. It is so incredibly easy. On the bottom of page 194, are you reading along? In many cases, the name of ionic compounds are quite straightforward. Just as is in the chemical formula, the name of the metal is first, followed by the name of the nonmetal. However, the ending of the name of the nonmetal changes to I. For example, the compound formed by calcium and iodide is called calcium iodide. The compound formed by aluminum and sulfur is aluminum sulfide. Okay? Table 1 gives the names of some nonmetals in ionic compounds. So fluorine becomes fluoride, chlorine becomes chloride, bromine bromide, iodine iodide, oxygen oxide, sulfur sulfide, nitrogen nitride, phosphorus phosphide. Just add I. That's all you do. Okay? Now, for those of you that are going to go on and take grade 11 chemistry, pay attention for about 30 seconds. Those of you that are not, put your head down. Do not listen to me. If you listen to me while I'm teaching this, you're in big, big trouble. If you're planning on taking grade 11, please listen. There are names and formulas for atoms with more than one ionic charge. Some elements have more than one ionic charge. They're kind of weird. Some metals are able to form more than one kind of ion. For example, the element copper forms 2 completely different compounds when it reacts with chlorine. One of the compounds is white, the other one is yellow. Christian, are you listening? No. Good. Chemists have found the ionic charge on the copper in the white compound is 1 plus. Its chemical formula is CuCl, since the ionic charge of chlorine is always 1 minus. The ionic charge in the copper in the yellow compound is 2 positive. Its formula is therefore CuCl2. Table 2 shows the names and ionic charges of some metals that have more than one ionic charge. In other words, copper can be a 1 or 2 positive, iron can be a 2 or 3 positive, lead can be a 2 or 4 positive, and tin can be a 2 or 4 positive. They can be either one. Okay? These compounds are named in the same way as other ion compounds, except that a Roman numeral is added in round brackets after the metal to indicate its ionic charge. For example, CuCl is called copper 1 chloride because the ionic charge in the copper is 1. CuCl2 is called copper 2 chloride because the ionic charge in the copper is 2. Remember that you have to use the Roman numeral system only when naming the ions and metals that you can have more than one ionic charge. So in other words, if it's one of those ones, they're called polyatomic. Okay? They can have more than one charge. So those of you going on to grade 11 chemistry would be expected to know that. Okay, we're going to do some practicing. You weren't supposed to be listening. You might have got some extra learning today that you didn't deserve. Shame on you. Sarcasm dripping from my voice. Okay, I know this is a ton of questions. That's probably way too many, right? That's probably way too many. Let's leave out number one. Scrap number one. Let's scrap number two. Let's do 3. 3 and 4 go together. 5, 6, 7 is only for people going on to grade 11. Chem, do not do 7 if you're not planning to go on to grade 11 chemistry. If you're not sure, do it. Same thing with 8. I'm not sure about 9. I want everybody doing 3, 4, 5, and 6. If you're planning to go on, please do 7, 8, and 9. Okay, I'm going to check these very soon. There's another hand in coming. Basically, you guys, there's going to be a hand in every time that I need to check to make sure you know what you're doing. This is the practice. Then I'm ready to go. It's hand in. I get the marks. I'm good. I understand. Go. Let's look at lithium and fluorine. Lithium and fluorine. Okay. Where is lithium on the periodic table? If you look at the table on page 192, it gives you the charges. Lithium, I think, is a first column, is it not? Group 1, positive what?
1.
Positive 1. 1 positive. Where is fluorine on the periodic table? Way over on the right. I think it's group number 7, is it not? It's a negative 1. What do we do with those charges?
Crisscross.
Crisscross them over. There and there. Your formula then is LIF. Is that not what I spent 11 minutes and 52 seconds describing?
Anyone didn't explain it very
Yeah.
Dylan didn't need to. I did it. This is sort of how school works. I explain, and then you practice. If you don't pay attention during the explaining part, you don't do very well at the practice part. Try the next one. We'll check it right away. LIF. All I did was ask you what the 2 elements were. In 3B, what are the 2 elements? What are they? Calcium and bromine. Okay. If I'm not mistaken, I've done a lot of calcium, drinking a lot of milk over the years. Yeah. Calcium, I think, is a 2 positive. Am I right?
Yeah.
Am I right? Donovan, calcium is a 2 positive?
correct.
I am correct. I don't hear that very often. Thank you. 2 positive. Bromine, I think, is a... Chance, what's bromine? Where is it? On the chart where, Chance? Look.
All
Look.
down there, right there, right where you.
So what's the charge? What's the charge? It does. It has how many negatives right there? Chance. 1. 1 negative. So all you do is cross them over. What is witchcraft? What is your formula? CaBr2. That's all there is to it. That's all there is to it, you guys. I know it's boring, but it's not hard. Try the next one. Go. The next one is sodium, which is Na, and what's the other one? Nitrogen. Sodium is a 1 positive. Nitrogen is a 3 negative. Crossover. Na3N. It's easy. You just gotta do it. Cole, what's the next set? Yeah, I know. What's the next set? Aluminum and nitrogen. Aluminum we did already, right? Aluminum is A. Aluminum's a 3, right? Okay. Aluminum is a 3. Nitrogen is a 3. Oh, what do we do here? Is it going to be Al3N3? Hey, this is important, you guys. Listen here. Is it going to be 3 and 3?
No.
Seriously.
I thought you were going to go back in your phone, so I just...
Should I leave it as 3 and 3?
No.
What should I do? It's kind of like a fraction. Do I need 3 aluminums for every 3 nitrogens, or could it just be 1 to 1? 1 to 1. The 3 sort of cancel out. So if they match up like that, it's just going to be AlN. Okay, if you can cancel them, like if what if it was a 6 and 3, then it'd be a 2 and a 1. It's just like fractions, reducing fractions. And I know you guys have done that. Okay? Now, the next question, question 4, is you're supposed to name these things. So LiF is going to be lithium fluoride. Calcium and bromine is going to be calcium bromide. Basically, you just write the letters, Sadie, the names, with I at the end. NaN is going to be sodium. Nitrogen becomes nitride. AlN is going to be aluminum nitride. Okay? Easy, easy stuff. Go on and do number 5 now. Start right now. Do number 5.